Hi everyone, and welcome to another episode of Mathematical Mowbray Movies. In this episode we're looking at scale diagrams and house plans within that same kind of context. So I thought I'd just start by showing you, I think I've told you before that my husband is an architect, so he's often using scale diagrams, so this is just an example of one that he's using at the moment. So you can see that this is a big block of land, and on that there's some different buildings that he's been doing some work on. And you can see down the bottom here that there's a scale that's given. So the scale is 1:200, and that means that 1 centimetre on this diagram is equivalent to 200 centimetres in real life, or 2 metres in real life. So they use this scale, and the builders will use this scale when they're building the project. So scale diagrams are a really important tool, particularly in the building and trade industries. So that's what we're looking at in this lesson. So just as I've explained, a scale diagram, just to give us a definition, a scale diagram is just a diagram that shows a reduction or an enlargement. So we might use an enlargement for something like if you're looking at a small object under a microscope, then you draw a larger diagram than the real object. But it's a reduction or an enlargement of a real object. And we give a scale as a ratio, just like the one that you saw, 1:200. So an example here is 1:10. So this means that 1 centimetre on my diagram, on my scale diagram, is equivalent to 10 centimetres in real life. So that's how these ratios work. Sometimes these scales are presented in other ways. So you would have seen on that diagram again that the scale was also presented in this way. So you guys can't tell from the video, but if I just did a quick measurement, you can see that this is a centimetre, that little black bit there. So in this particular diagram, or in this particular scale, sorry, I can see that 1 centimetre, there to there, is equivalent to, in this case, 5 kilometres. Now, that's okay as a ratio, but to give it as a proper ratio, I need to have no units, which means that I need to convert this to the same, these two units to be the same. So to do that, I'd turn kilometres into centimetres. Just a reminder how to do that conversion, kilometres into centimetres. I need to times by 1,000 and times by 100. So I'd just be looking at my 5 kilometres, and I'd be timesing that by 1,000 to turn it into metres, and then by 100 to turn it into centimetres. So here I can say that 1 centimetre is the same as 500,000 centimetres. And once I have those as the same units, I just get rid of them. So my scale here is 1:500,000. So that's one example. This is a similar example. It's obviously written a little bit differently. They've got the word 2 there. But this is just 10 millimetres is to 1 metre. Again, I need to get these into the same units. I'll convert metres into millimetres. So I do that by first timesing by 100 to convert to centimetres, and then by 10. So my 1 metre times by 100, I'm doing it on my calculator so you can see, 1 metre times by 100 to turn it into centimetres, times by 10 to turn it into millimetres. So I can see that 10 millimetres is equivalent to 1,000 millimetres. They're the same units now, so I get rid of them. And this is 10 is to 1,000. Now you can see at the moment that that's not actually the simplest form of this ratio. And so really you want to be able to simplify that ratio. And you can do that by entering it into using the fractions button on your calculator, and seeing what equivalent fraction that produces. So if I don't have quite the same calculator as you guys here, so I can't quite show you on this one. But if you just press what you know as that normal fraction button that has this kind of diagram on it, and you enter this as a fraction, 10 over 1,000, and you press equals, it'll give you the simplest form of the fraction, and in this case it would be 1:100, since what it's done is that it's divided both sides of this equation by 10. So this is the simplest form. The last one over here, 2 centimetres is to 4 metres. Again, different units. I need to turn my metres into centimetres by timesing by 100. So I'd get 2 centimetres equals 400 centimetres. I get rid of my units. Get 2 is to 400. I should write this as 2 is to 400 so that makes some sense. And then again, I'd enter it into, using the fraction on my calculator, I'd enter it as a fraction. I'd press equals. What that will do is that it will simplify the fraction to its simplest form, which I then rewrite as a ratio. So that's simplifying those ratios and the different presentations of the ratios. Sometimes you might be asked to find the ratio. So you might be told, for example, that a 15 centimetre pencil is drawn to scale, and in the diagram the pencil length is 5 centimetres. And they'll ask you what scale's been used. So remember, a scale shows you the distance, or sorry, the length that is on the diagram in ratio to real life. So in this case, I'm told that my pencil on the diagram is 5 centimetres, but in real life it's 15 centimetres. These are already the same units, so I can get rid of them. 5 is to 15. Again, entering it in on your calculator using the fraction button and pressing equals will simplify this to 1 over 3. That's my ratio, 1 is to 3. So that's the scale that's been used. We can use these scales to find a real length from a diagram. So a builder would use that plan that I just showed you before, that my husband's using, to work out, you know, different measurements and things like that. So they use a ruler to determine that. So I can do the same thing here. So I've been told that this tennis racket diagram has a scale of 1 is to 12. 1 centimetre on the diagram equals 12 centimetres in real life. So if I was asked to find the length of this, you can see that this is 70 millimetres or 7 centimetres. So that's what this shows me. So I'm going to say, just for to make the calculation a bit more straightforward, this diagram shows that this length here on the diagram is 7 centimetres. So if I know this diagram is 7 centimetres long, but I know in actual fact that the ratio is 1 is to 12, then I need to work out the actual size of the tennis racket. And since this is 12 times bigger, that's what I'm going to multiply my, my 7 by. That's the scale factor from our last video. So this is going to be 7 times 12, and 7 times 12, you can do it in your calculator if you want, but hopefully you know your times tables, just gives you 84. This is 84 centimetres. On this diagram here, I've got a slightly different one here. In this case, this is a little ladybug, or my best diagram of a ladybug, but in this case things get smaller. This is a bigger, well, it's probably the world's biggest ladybug if you've ever seen one like that. So what I've said here is that in this diagram, 7 centimetres is equal to 1 centimetre. So 7 centimetres on the diagram is actually bigger than real life. Okay, sorry, shouldn't be the diagram equals real life. This is the diagram and this is real life. So again, I'm going to measure it. When I measure it, I can see that it's 3.5 centimetres long in my diagram. So I've got to say to myself, well, how long is this actually going to be in real life? So I know my ratio here is 7 is to 1. 7 centimetres in the diagram is 1 centimetre in real life. So I say to myself, how do I turn that 7 into that 1? What's the relationship there? And in this case, it's divide by 7. Real life is actually 7 times smaller than the diagram. So the actual size here, well, at the moment my diagram is 3.5 centimetres, but I need to divide by 7 to work out what real life is going to be. So performing that calculation, I'd see that my actual size is 0.5 centimetres. Another way you can do these calculations, and this is just for those people who want to know, is that you can set up equivalent fractions. So I can say that I've got a ratio of 1 is to 12, and what's going to be equivalent to that is what I'm looking at. So I know that this is on my diagram, and this is in real life. And so I say, well, on my diagram, I also know that the tennis racket is actually 7. I'm trying to work out what it is in real life. And I can use cross multiplying there. So remember, cross multiplying means multiply the two things that are opposite and divide by the thing that is opposite, the unknown. So here the question mark would be given by 12 times 7 divided by 1, which again will just give you the 84. On this one, if I was to use that same process, the diagram in proportion to the real thing, here my scale tells me that the diagram is 7 and the real thing is 1 from my scale. Now I know from my measurement here that I've got a measurement of 3.5 centimetres. I'm trying to work out what it really is when it's the lady beetle. So I'd cross multiply times the two things that I know, and then divide by the number that is opposite the unknown. This will give me 0.5 again. Last calculation we're just going to do. In this case, I'm using scale diagrams to calculate the area of a room. So just a reminder that the area is given for a rectangle as length times width. And so here you can see I'm given these measurements here for this particular room. Architects always work in millimetres because they've got to be very precise when they give diagrams to builders for the building work. So the first step here is to make sure that you convert these measurements into metres before your calculation. So a reminder that you do that by dividing by 10 and then dividing by 100. So 7,600 mils. Once I divide by 10 and divide by 100, that will be 7.6 metres. 15,000 mils will convert to 15 metres. So then my area calculation, which is length times width, will just be given by the length of this room, which is 15 metres, the width of the room, which is 7.6. I multiply those two things together, and I get 114. This is now, the units are metres, but it's metres squared because it's in 2 dimensions. So I need to put metres squared. That's all we're going to do on scale diagrams, so all the best with that. I hope you understand how that all works. If you can now have a go in your textbook at exercise 303 and 304 in class, if you want to ask me which particular questions you need to do, if you feel like you're going, progressing quite quickly, then just let me know. But if you can have a go at those 2 exercises, then that will help you to see how much you've learnt from this video. Good luck!